Alright guys, so I wanted to do a couple of videos for you. It's been a week and a half since I've been able to meet up with you, and wanted to just make a couple of videos and hopefully help you out as you're doing some of this quadratic stuff. Most of this should be reviewed. And what isn't, I mean, you do get your calculator for most of it anyway. So I'm going to share a couple of things with you today. But again, I'm going to expect that you're able to use your calculator a little bit as well. Alright? So, here's our first example. This is the first video that we'll have. We've got the side view of a suspension bridge can be modeled by the equation f of x equals da 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 da, and you got your squared here, so we know it's a quadratic. Another thing I want you to mention is notice is that the coefficient of the x squared here is positive, which means it's going to have kind of a normal curve like that. All right. It says x is horizontal distance from in meters, and f of x is the depth in meters. Okay, so first it asks us to plot the graph. You know what, I'm not going to do the graph right away. I want us to actually do the other pieces first. Those other pieces are going to help us to plot the graph properly. Alright, so letter B says find the coordinates of the points where the graph crosses the x-axis. Now those are the x-intercepts. Now you should know that to get the x-intercepts, we're going to make y equal to 0. So I'm going to go ahead and make y, or in this case f of x equal to 0. So it's going to be 0 equals 0.00097222x squared minus 1.167x. Now that's a basic understanding that you should have, is that to get the x-intercept we make y equal to 0. Now once you have this, you should be able to insolve it on your calculator and just go like this, comma x, and you should be able to solve for the x value there. Now we should get two different x values. Okay, the first one should be at x equals 0, and the other one should be at x equals 1200. All right, so there you go. You got the 2 points where the graph crosses the x-axis. Okay, letter C asked us to use these values to write down the equation of the axis of symmetry. Well, the axis of symmetry, remember, is a line that goes straight through the middle of my graph. Now, how do I use the x-intercepts to help me get that? Now, you may know some other ways to get the middle of your graph. You may know that you can plot it on your calculator. And use the minimum function. Right? That would give you the center of the graph. It would give you the vertex there, which you could get that symmetrical line from there. You learned back in Algebra 1 that you could do the x value of the vertex equals negative b over 2a, which comes from the ax squared plus bx plus c form of the equation. So you could use that. But this is actually asking us to do something different. It's asking us to use the values from b, which is the 2 points where it crosses the x-axis. So think about this for a minute. If this is my x-axis right here, and it crosses at 0, and then again at 1200, knowing that this line right here, the axis of symmetry, should go right through the middle, can you tell me what x value it should be going through right here? Well, hopefully you guessed 600. And that's exactly right. It needs to be 600, so it's right in between those two. If it was a little bit to the right or left, then it wouldn't be symmetrical anymore. So it's important that this goes right down the middle. So you can always, to get the x value of the vertex, you can take your two x-intercepts and average them. You can do, sometimes the x-intercepts are shown using Q and P. So you can take x-intercept number 1, x-intercept number 2, and then divide by 2. And that'll give you the average value, the value going right through the middle. In this case, 600. Alright? So we now know that the axis of symmetry. Now the axis of symmetry is an axis at this. Notice that this is an x value that we're going through. So it's at x equals 600. And that's my axis of symmetry there. All right. Now, in part D, it says use part C to find the y coordinate of the minimum. Now, that should be easy enough because I'm just going to take my x value and I'm going to put it into my original function, right, for x here and solve for y. And so the y value of that minimum we can calculate on the calculator. Just punch it in. Beep, 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 beep. And you should get negative 350. All right? Go ahead, double check that on your calculator. You should get the same answer if you did any of those previous methods. However, we're trying to learn how to use the x-intercepts here. All right? So, first we found the x-intercepts in part B. Then we used those to find the middle value, which was my axis symmetry, which I then used to get the y-coordinate, which now gives me my complete vertex. Now, at this point, I can go ahead and do the go back to A, which is to plot the graph of the function. And you can see that I kind of plotted it as I was going, right? I've got my x-intercept here at 0. I've got an x-intercept here at 1200. And then I've got my minimum now, which is at 600, comma, negative 350, which is what I just came up with. And that's a pretty good plot of the function. That's all that's needed, all right? The only other thing that we need to do here is describe in this context what the minimum point represents. Well, this minimum point, 600, negative 350, represents that halfway across the bridge, or at 600 meters, that the suspension bridge reaches a point negative 350 meters below the x-axis or the origin there. Okay? And so that's enough to be able to describe that that's the lowest point on the suspension bridge. All right? Hopefully that makes sense. Let's go ahead and you can turn to the next video and I'll go through another one with you, all right? Awesome.